Today's lecture will be on adaptation and mitigation strategies to climate change impacts. So here you can see the global water availability and use per capita. So if you observe this map carefully, you see India is at the higher side of water consumption per capita. So his color is nearly what I would say in the orange color, and what I can see is here this one is India, this is the Indian subcontinent, and if I see the water uses per day in liter, this is also in the higher side. It is nearly in this region 1505 to 2358 liters per day per person. So you see here it is nearly 1505 to 2358 consumption, water use, and water resources is also in the same range. It is little bit lesser. Water resource is less than consumption. You see, if this range I see, I assume this, I take this value. So 1791 is the resource, the available resource. Okay, and this is the uses is I've taken the higher range, so let me take this. In this case also I will take the higher range. It is 2358. Correct. So you can see that already the use of water is more compared to the availability of water resource. So that's a important thing to consider. Okay. Now let us take another data. Global scenario of water availability and so global scenario of water availability and demand. So if you can see this, you can see that in Asia, this bar, what is this bar? This bar is indicating per capita water availability. Okay, and this bar, this big bar, is indicating the total water availability. So you can just observe in this chart, you can see that out of 13510 kilometer cube per year, this is the total water availability in Asia. We are using only 3.92. That is another very remarkable data. So here I see that in Asia more water is available than used. However, in case of Australia, you see, and Oceania, more is used than available. Correct? And the most optimal stage or optimal status is observed in case of South America, where you see then more or less around 50% of water is being used. Okay, so and if I see this chart, average water use per person per day in different countries, you see India is not a very high consumer. Average Indian person doesn't consume much compared to USA. So in case of USA, 575 liters per day, one person is consumed. But in case of India, 135. So by use, you cannot say that India is consuming much. Now let us see the demand per capita. So we have compared the India, then China, then US. All this we have compared. You can see that US is far ahead in case of water demand. And this is, you see, this black bar is indicating the 2000 water demand, which was more in US, and this blue bar is indicating what is being predicted. This is year 2050. This bar is the water demand in 2000. In the year 2000, this was the water demand for USA. And this blue chart is indicating what is being predicted to be the water demand in 2050. So here see, in case of India, if we compare, water demand is far less than USA. But the interesting point to note is, if we compare this India and China, water demand is more in India in case of 2000 as well as in case of 2050. Okay, so that is a point of concern, right? And if I see if I observe or if we compare how this water is being used, in case of India, most of the water is used in agriculture, 83%. And compared to the world water use, in world 69% of water is being used for agriculture. But in case of India, it is 83%. And in case of world, 23% of water is being used in industry. Now, which is compared to world, India is a very minimum user of water for industry, only 12%. So it is very natural because in world, here also in Europe, which most of the countries are high industrialized, that is why 54% of water is used for industry. Compared to India, it is only 12%. So it depends upon how much industry is there in your country. So now we'll see the status of water resource in Northeast India. So if I compare all the water resources of Northeast Indian states, you'll see that this blue color is indicating tank or pond or lake surface water bodies. Availability of tank, pond or lake water, this blue bar is indicating. The red bar is indicating the spring water. Okay, that's the river water. That's not spring water, small springs are there. So this is for spring water. And this green color is indicating the river water. So this is actually the river water. And in case of this color, these are all other sources. So if you can compare all the states of Northeast India, Arunachal, Assam, Manipur, Meghalaya, Mizoram, Nagaland, Sikkim, Tripura, you can see in case of Manipur, there are large, highest amount of water is there, and within that water availability, most of the water is available in tank, followed by river water, then it is spring water, and ultimately the other source of water. But in case of Meghalaya or Mizoram, you can see most of the water is spring water. Okay, not tank water or not river water. Most of the water is from spring. Take the example of Sikkim. If I take the example of Sikkim, you see the maximum or the most, here also I will say the most of the water resource or the source of water is, you can see it is red. That means spring. Spring water. Small, they say it as chora. They say that as chora, which is popularly known as spring water. Okay, so that is what. So main drinking water source in total households, where household water is supplied. Here also, if you see, they have utilized some colors. Where this blue color is indicating the treated tap water, red color is untreated tap water, and this is for other, and this orange color is for tubal. Okay, this is tubal. Tubal water. Okay, and this one, this color is from pump. This is for hand pump water. Okay, and after that, this mauve color is indicating uncovered well. Green color is indicating covered well. So let us summarize again. This blue color is indicating treated tap water. Red color is indicating your untreated tap water. This is UT, untreated tap water. This is T. This green is covered well. So I can say this as CW. And this mauve color is indicating the uncovered well. And this greenish type color is indicating the hand pump water. This orange color is indicating tube wells or bore wells, groundwater basically. And this color is indicating other resources. So if I compare all the states of this Northeast India, you can see that sorry, in case of Arunachal Pradesh, maximum water is coming from untreated tap water. In case of Assam, maximum water is coming from hand pump. Manipur, maximum water is coming from other sources which cannot be classified under treated, untreated tap water, covered well, uncovered well, hand pump, etc. Sorry, followed by this treated water. So Manipur is having maximum treated water, followed by maximum other type, but classified source is treated water, maximum. And for Assam, I have already discussed hand pump, HP. And for Meghalaya, here also treated water, treated tap water, correct? And other is constituting the maximum share. In case of Mizoram, also same. treated and other constituting the maximum share. In case of Nagaland, you see untreated water has the maximum share. In case of Sikkim, also untreated water maximum share. And in case of Tripura, uncovered well treated tap water constitutes the maximum share. So this is what is the way water is supplied from different drinking water source for the northeastern states of India, and this is the water resource type of water availability in northeast India. Mind that. Now, if I see some climate change vulnerability, how vulnerable is the state of Tripura with respect to climate change as per the scenario RCB 2.6. So this RCB means representative concentration pathway. For whose concentration? Carbon concentration in the atmosphere. Representative concentration pathway, RCB. And 2.6, so it is saying that if the temperature is increased by 2.6 degree, then sorry, not 2.6 degree, only 6 degree, then what is at present is, then what will be the impact of the change in that climate on Tripura, right? So this is for your, let me summarize this. 2.6 means 6 degree centigrade increase. Then the average temperature of the world, or I can say average temperature of the world before industrial climate take place. You know, before industrialization take place. So let me explain it a little more. Uh, Actually, in economy, they consider that uh, pre and post industrialization area. The time when uh, the in England industrialization starts to prosper after 1940, and it prospered rapidly, and so rapidly that it covers the uh, entire England and all its cities. And the main issue is that due to this industrialization, lots of greenhouse gas is emitted in an uncontrolled manner in the atmosphere. As a result, uh, global warming started to take place, whose result is actually the change in climatic pattern of different places of the world. Remember, if greenhouse gases increases, then global warming will happen. Why global warming will happen? Because of this greenhouse gas can store thermal energy within their molecules. That is why what happens is the average temperature, atmospheric temperature get increased, which is indicated by the global warming, or known as the global warming. And once a global warming happens due to the increase in GHG, which is not a very normal state, normal scenario, what happened is the climate started to change. And as a result, we see changes in climatic pattern of many areas of the world. And due to this change in climatic pattern, how different area respond to that change, that is being studied extensively nowadays. And this vulnerability index actually indicates that how vulnerable or how compromisable is the state of Tripura to climate change. Okay, and to represent climate change, we have some representative concentration pathway. There are 8 in total, which depicts different pathway by which greenhouse gas can change, or by which the average atmospheric temperature of the world will change. So here 6 indicates 6 degrees centigrade. There are 8 also, so which indicate 8 degree increase than the average temperature of the atmosphere. And there are many different other 6 different scenarios also available. So these are all only indicates different climate which may take place in the world if 6 degree or 8 degree or 4 degree or 2 degree centigrade is increased compared to what we have observed in pre-industrialization time. So 1940 is the threshold. Before that is pre-industrialization, and beyond that is post-industrialization. By increase in 6 degrees centigrade, we indicate that increase in 6 degrees centigrade compared to the average temperature of the world at the time of pre-industrialization area, not post. Okay, so this is the vulnerability of the state of Tripura district-wise. We have divided the state of Tripura into 4 different parts. Now, in recent years, this is 8 districts are there. But let us see, we have divided the state of Tripura into 4 distinct parts. And in these 4 distinct parts, this red color indicates how vulnerable Tripura will be. As per the climate represented by the representative concentration pathway RCP 2.6. Here you see only the south part is vulnerable, little bit vulnerable in case of 2010 to 2019. That is a baseline period. Only this part is little bit vulnerable. This is West Tripura, this is South Tripura. Okay. But in the year 2020 to 29, you see, in 2010 to 2019, there are only 2 districts, 1, 2, which are vulnerable, moderately vulnerable. 220 to 2029, 3 districts. 230, 2030 to 2039, 1, 2, 3. Now this district is more vulnerable compared to this and this. In 240, 2040 to 2049, what do we see? We see that 2 districts, 1 and 2, become more vulnerable compared to other districts. You see, this in the year 2010 to 2019, these 2 districts were vulnerable. In case of this 10 years, we see this district, Tripura West district, is becoming more vulnerable compared to this one. Okay, and in the year 2030 to 39, what we find is this become more vulnerable, this become heavily vulnerable, and this is now slowly becoming vulnerable. In the 240 to 49, you see now this has become very vulnerable, this has become extremely vulnerable, and this is becoming vulnerable, and so on. Here also this intensity is increasing for these 3 districts. The positive point is that this part of Tripura, this is the North Tripura, is remaining moderately vulnerable throughout the prediction years. That means from 2020 to 2059. This is not 5059, this is 2059. So from 2020 to 2060, this is moderately vulnerable, although it is becoming vulnerable now in this zone. Now, why this is so? Because what we find is uh, this part of Tripura is still naturally sustainable with large percentage of forest cover, naturally sustainable we say, because of the forest cover and all this thing. But forest cover is receding rapidly in west because of the urbanization. Here also the south, this is also rapidly decreasing because of urbanization. And what we find is from this study, you more the urbanization, more will be the vulnerability. So this is for 8.5, as I already said, RCP 8.5. So it is also known as RCP 2.5, 2.8. Sometimes it is called so. So it is actually this scenario represents plus 8 degrees centigrade. Okay, so you see for this is the baseline scenario. This is the actual scenario, what it is at present. But this is prediction, this is prediction, this is prediction, this is prediction. And you will see, if you observe this thing, you will find the result is more or less same. Due to 8 degrees centigrade, only thing is that intensity of vulnerability will be more. You see this area, how vulnerable it is. Most. Just compare this, these two. Okay, so for 8 degrees centigrade, it will be just intensity of vulnerability will be more. So this is the comparison of water availability and water demand in 4 of the major rivers of Tripura. This is Howrah River. It flows through the capital city of Tripura, whose name is Agartala. This is Gomati River. This is Monu River, and this is Khwai River. And there are 6 to 7 more rivers in Tripura, which are not major. One major river we have not used due to the lack of data, that is Feni. But in case of Howrah, it flows through a peri-urban to urban land use, flows through that. Gomati River also spans through a peri-urban area. Recently, due to urbanization in some cities, the impact of urbanization is showing in Gomati. And Monu River is more or less a rural area, close to a rural area. Khowai also, because the city which is placed in the banks of Monu or Khowai is not much urbanized. So this is a comparison between water availability and water demand. So here what is happening is availability is indicated by deep blue and demand is indicated by lighter blue. In this case, you see the main interesting thing is in case of this baseline scenario, this is known as BAL. This is already done, gone. Availability is more compared to demand. Situation is not vulnerable. You can see. Now availability is reducing in case of Howrah, but demand is increasing. Now availability get reduced. Demand has overtaken availability. More, you see, more, you see. Same situation in all these rivers. The intensity changes, but situation or pattern is same. So this is the water deficiency. This Howrah River is shown by this. Is it nearly 1 mega million cube water is deficient in 210, which is sorry, plus 1 mega million water in the baseline scenario. Which ultimately in the year 2050 to 59, this 10 years decade, this they say it as this is PL, this is predicted decade 1, this is predicted decade 2, this is predicted decade 3, and this is predicted decade 4. So in the P4 you see deficiency is maximum, nearly minus 3.4 or 5 mega million cube deficiency in case of Howrah River, which flows through rapidly urbanizing cities of state of Tripura. So you can see this red color is for mono, this ochre color is for Gumati, and this green color is for Khowai. So the situation is best in Khowai River only because it flows through more or less rural area with some very few city which doesn't have much urbanization. You can say it as peri-urban, neither more neither less. Peri-urban. We say it as peri-urban. So as a statement, Tripura has 35,000 liters of water annually per capita. That is double that of national average. Interestingly, it still has water shortage. So they are saying that due to deforestation and conversion of land use and contamination of water, this is happening. Availability is there, but utility is less. So deforestation is taking place due to urbanization. It creates different deforestation, which again create conversion of land use. Correct. So how to mitigate these extremities and vulnerabilities? How we can mitigate that? How we can compensate that? How we can stop this and reverse the trend? Okay. So let us see mitigation method 1, traditional water conservation method. We must return back, or we must start to implement what water conservation methods were practiced by our forefathers. Okay, so we must return back to traditional water conservation methods. This can be a very good solution. So by traditional water conservation methods, what we mean? You see, in case of northeastern states, there are mostly hilly area. Now, what happens is, most of the main problem of this northeastern states are due to this hilly region. What happens? Due to this hilly undulating region and a slope towards Bangladesh, a foreign country, most of the water that falls onto these lands flows away to Bangladesh. Take the example of the state of Tripura. 80% of its border, of its west side border, is Bangladesh. Okay, so and the slope is also towards Bangladesh. So after rainfall, most of the water goes to Bangladesh. This can be prevented if we create some trenches in the side of the hill. These water can be prevented from flowing out. So if this water can be prevented from flowing out, then lots of water will be available, or more precisely, we can increase the water availability. Now, this trenching thing is participated or practiced in, as you see here, it is written in most of the states of Northeast India, like Mizoram, Meghalaya, Nagaland, and Tripura. So, what are these traditional means? Let us see. So, this is very interesting. First one is rooftop water harvesting. This is self-explained, nothing to say. Bamboo pipes were used. Okay, so suppose in hilltops there is a surface water body. Okay, in the hilltop, far away from your house. What they do is they use these bamboo bridges or bamboo canopies to bring that water from that area to your house, such that loss of water can be prevented, which happens during the carrying of water from this place to this place. Okay, so this is practiced in Meghalaya for a long, long time. Now, let us say Jabu and Ruza trenches that I have already said, explained. Mizoram and Nagaland is practicing it for a long, long time. They say it as Zabu or Reza. This is known as Zabu. You see, due to this cutting of trench, what happened is this water from flowing out due to the slope, they are being stored here. That is the advantage of this method. Jabu in Mizoram, I think, yeah, and Rusa in case of Nagaland. Before that, most of the water flows out to Bangladesh. You see this, all this side is Bangladesh. So this was prevented by cutting trenches in the banks of in the side of the hill. Okay, now another method is known as Cheo Ojigi. Cheo Ojigi is a very interesting method. You can see the example here, case study. Okay, so now what they do is Cheo Ojigi is a method adopted by the locals, Nagaland's Angami villages. This is very important. Cheo Ojigi. So Majil River flows through that area. What they would do is, you see, tapping of water from hilltop streams, that means Majil River, with bamboo, long channels of bamboo pipes. Okay, and so as I have said earlier, they use bamboo pipes instead of any earthen pipes or any PVC pipe. They use these type of bamboo pipes. Can you see them? To bring the water from a far away stream. Maybe it is in the hilltop, maybe it is far away situated, but they use these bamboo tops to bring that water. This bamboo canopy or bamboo channels are very cheap, you can understand, but sustainable. Yes, I agree, not as sustainable as PVC or other pipes, but sustainable. And the moreover, as these areas is not very rich areas, so as bamboo pipes are very cheap, so you can understand why this is implemented widely. This method is known as Chio Ojihi in Naga words. Chio Ojihi. Okay. So another, let us say, so these are the traditional methods: Jabu and Ruja, Chio Ojihi, bamboo pipes, rooftop harvesting. This can be practiced to prevent loss of water from runoff. Correct. So runoff must be prevented anyway. So how you can do ancient methods like rooftop water harvesting? Yes, but practice that. Number one, bamboo pipes or chio ojigi. Yeah. So these will be your number two, and then you can find chabu ruja. This is number three. Correct. And also chio ojigi. Correct. So chio ojigi is a very nice thing, as I have already discussed. Bamboo pipes. That one was bamboo. This you can say as the fourth position. Okay, So, so let us see now other method, mitigation method. One is, as I have discussed already, first one is using traditional methods. Okay, guys, using traditional methods of water harvesting, uh, rooftop, bamboo pipes, then that Jabu and Rusa, which is actually the trenches, and also GOG method. This is also at bamboo pipes, but these bamboo pipe bring water from springs, nearby spring, and these bamboo pipe bring water from hilltop wetland. Okay, hilltop wetlands. Okay, so these two are different. Now the second mitigation method can be use of traditional water filters. So what are the traditional domestic water filters used in India, or more precisely Northeast India? There are various types of water filter, traditional water filter utilized in many parts of India as well as Northeast India. So it can be filtration through winning sieve, filtration through cloth, clay vessels, plant parts, stone filter method. It can be in many different ways, but mainly these five different methods are observed. Okay, so let us see, for example, yeah, this is first one, filtration through winning sieve. They are very self-explanatory in nature. There is a porous plot here. You see, this is the porous plot, porous clay pot. So first, the supply water is stored here, or not supply water, I would say water from outside is stored here. This can be referred as contaminated water, not untreated water, right? And due to the small pores in the clay pot, this water, this untreated water, seep through it and falls in the next, what I can say, next pot into which this first pot is placed. Here, this is the picture. You can see, it will be more clear from this. This is the first pot. This is your untreated water. So due to the small pores in this clay pot, water seeps through it and stored in this pot, this outside pot, which is actually the treated water. You see, clear treated water. Very simple process, but very useful process. With the application of this filtration system, you can remove most of the suspended matters. You can also remove some microorganisms, and some heavy metals also can be removed, but all the most of the suspended matter is removed in this type of filters. So this is filtration through cloth, self-explanatory image. This is your cloth. So this is fine sand. This is charcoal. This is coarse sand. This is rocks. So while this is the untreated water, so water seep through these layers. So separate the different layer, remove different contaminants. I've discussed about those later on in this presentation. So it flows to rocks, it flows to coarse sand, flows to charcoal, fine sand, and ultimately through a cloth. So nearly all suspended particulate matter, or TSS, is removed by this filter. Highly turbid water becomes very low turbidity after filtrating the same with the cloth. Okay, so these are all traditional water treatment practices. This is filtration to clay vessels. There is no external vessel here, only clay vessel, which is used for filtration. Now, as I say, filtration through plants, you can see that this is the This is your untreated, actually this is your untreated water. This is your untreated water. Okay, so water level is risen by the application of untreated water, and this type of filtration is used mostly beside the swimming pool. So untreated water is placed here, water level rises, goes to this part, flows through the water plants and then through this gravel, and then from here it filters out. Due to this gravel and due to different types of plant, most of the contaminant of the water is removed. This water flows by gravity to the back to the swimming pool, and there is a dividing wall in between this layer and this layer, water layer, such that water cannot come through that. Okay, it must come only through this part. Top level. Top level water is contaminated, so they are being allowed to do that plant area. So this is another type of filtering method, jumping stone filter method. This is untreated water, as you can say. This is untreated water, clay water, muddy water, whatever type of water may be. This is a cylindrical Catus container, and this is the clear water. Here also, most of the total suspended solids are removed. So turbidity get drastically reduces due to this type of traditional filtration technique. But other contaminants like microorganisms or bacteria, they are very hard to remove by this type of traditional method, which I will discuss later on. Now, here from our Veda, ancient Veda, Rig Veda, they have already defined the following properties of water or characteristics of good water, which will be beneficial for drinking. Mind you, this is drinking water, beneficial for drinking water. Shitam, cold to touch, water must be very cold to touch. Susihi, clean. Shivam, contain necessary nutrients, minerals, and trace elements. Istam, transparent. The water must be istam, transparent. And Bhimalam Lahu Satgunam, healthy acid base balance. That means the water must be neither acidic nor basic. Okay, so Sitam, cold water, Suhi, clean water, Shivam, all nutrients must be there, minerals and trace elements. Shivam is important. Nowadays, and Istam, transparent water. Lahu Shidganam means healthy and healthy acid base balance. Okay, so a very good drinking water or appropriate drinking water is, cold to touch. Remember, cold to touch. Transparent, clean, nutrient rich, and lastly, healthy acid base balance. Neither acidic nor basic. So this is the characteristic of a good water. Now I have already previously I was saying I will discuss about the common impurities and how you can remove that. You can see here a very interesting thing. Suspended solid, these are all the common impurities, and these are all the type of filters that can be used to remove those impurities. So here see suspended solid can be removed by any gravity filter, as you see there in the traditional filters. Odors and taste can be removed by activated carbon or charcoal or by simple addition, odors and taste. Now, odors and taste can be removed by that filtration through cloth. So that is why they use the charcoal, so that odor and taste, odor can be removed, taste can be increased. Hardness due to calcium and magnesium ions. For this, you need ion exchange. Traditional filters cannot remove calcium or magnesium. Microbes can be removed by physical filters, as I was saying, but mostly they are not as efficient as reverse osmosis filter. If you use a reverse osmosis with UV, then removal of microbe is optimal. And heavy metals can only be removed by reverse osmosis, no other way out there. Heavy metals can only be removed by reverse osmosis, no other way. Okay? And inorganic contaminants like sorry, nitrates, sulfates, etc. These can be removed by your reverse osmosis and ion exchange, both. And organic materials like volatile organic compound, VOC, microbacteriums, etc. Charcoal can remove. So this filtration through cloth can remove not organic materials also, that is volatile organic compounds, microbacterium, as well as it can remove odor and increase its taste. Just the introduction of charcoal in the filtration system does all this thing. So more or less, in summary, you can say that common impurities of contaminated water is suspended solid. This is the most common impurities. Suspended solids, or many times we see total suspended solid. This is the most common impurity available in all the untreated water collected from surface sources, which can be removed by physical filters, fortunately. Okay, by that gravity filter, by flowing the water through different sizes of stone chips or materials, gravels, sand, etc. Now, after the suspended solid, next dreaded contamination is your organic material or microbacteriums. It can also be removed by the use of activated carbon or charcoal. But remember, charcoal is not as efficient as the method of reverse osmosis. You can remove microbes, organic materials, microbacterium, etc. by the use of charcoal and also by the use of RO, reverse osmosis method. But RO is naturally more efficient compared to charcoal. Okay, so this to be noted, and also you can see the chlorine is another very direct contaminant. There is a level of chlorine that is allowed in drinking water, but if the chlorine is more, that drinking water is highly reactive, so that is why it can damage your liver or even kidneys. So this, just note, chlorine can also be removed by this one, charcoal. Charcoal is also known as activated carbon. So for only for hardness removal, you need ion exchange, and for heavy metals, you need, yeah, you see reverse osmosis or simply distillation will remove them. For inorganic contaminants like nitrates, sulfates, reverse osmosis or ion exchange. Beside this, activated carbon and gravity filter can remove all other types of contaminant from untreated water. So if you are planning to buy a filter, just check that whether a layer of charcoal is already there or not. Most of the low cost filter are gravity filters, but if you do not have the charcoal, then the problem is that you cannot remove odor, you cannot remove, this is more dreaded, you cannot remove the microbes or microbacteria. These microbes also include the cholera virus, Vibrio cholerae, Salmonella typhi, all these dreaded virus. Typhi causes typhoid. All these dreaded virus is classified under microbe, which can be removed by that charcoal. And also by reverse osmosis. Reverse osmosis is more efficient but costly. Okay, this is more efficiency means always attract cost. So reverse osmosis is costly but more efficient. Charcoal is cheap, less efficient, but can remove microbes. So after that, this is what we can see is that how we can select the best filter. Yes, as you know, the most important characteristic of a good filter is its contaminant removal efficiency. How well it can remove contaminant. Then, what is the cost or frequency of maintenance required? Then, what is its buying cost? Then, how many filter it has included in that buying cost. This is also very important. Remember, not all money. Remember that one single filter material cannot remove all the contaminants from the water. That is unfortunate, but that is true. So here I have shown you a comparison between traditional and modern filters. You see that what I was saying is contaminant removal efficiency in traditional filter is moderate. That means traditional filters means that gravity filters that I have just discussed with you, filtration through cloth, filtration through stone, filters through that material, special material, all these come under traditional filter. I am talking about this thing. Let me see. Filtration through clay vessel, traditional filter. Filtration through cloth. Filtration through winnowing sieve. All these are examples of gravity filter. Jumping stone filter method. This is also gravity filter. So by gravity filter, you can of course remove suspended solid. You can of course remove microbes, some amount of it. It will depend upon the diameter of the materials you are using in the gravity filter. And so, but the efficiency is moderate in case of traditional filters. In case of modern filters, by modern filter I mean UV, RO and UV, or RO plus ion exchange plus IE plus suppose UV. So these are all modern filters. So its contour removal efficiency is not only high, super. And maintenance requirement, this is interesting. In traditional filters, minimum maintenance. But in modern filter, you see, in case of RO, ion exchange, high. Because you have to remove all the salts from the ion exchange. Here also all the impurities from the other part of the RO, reverse osmosis filter. Now it is not as it is high in case of requirement is high in case of RO ion exchange, but low in physical filters and moderate in UV or distillation type of filters. Now as usual, cost of purchase is very low for traditional filter, but very high for RO or ion exchange, low, moderate for UV and distillation. And arrangement of filters is of course low. In case of traditional, you can mostly get gravitational filters, and yes, in some case charcoal, like filtration through cloth. But in case of modern filter, yes, mostly all type of filters are there arranged optimally. So I am saying that modern filters are of course efficient compared to traditional filters, but costly compared to traditional filters. Now, if you want quality, go for modern filters. If you want to save money but want to drink treated water, then go for traditional filters. Yes, so there are some rejuvenation methods for traditional water filters, but their requirement is very low. And Yeah, so there are uh, these are to make trade-off. We can use the traditional techniques of filtration along with the advancement of technology. Yeah, so this is very interesting thing that as there are in case of traditional, they are not efficient but cheap, correct? But modern, they are efficient but costly. So many scientists all over the world is trying to make a trade-off in between it. So cost and efficiency, they are trying to make a trade-off. Okay, these research results in these filters, ceramic pot filters. They are already installed in Cambodia. Okay, then you have three pot methods. Okay, you see pot one is for muddy water, pot two is for clear water, pot three is for drinking water. So here also easy to use, cost effective, let you use the dart and all. Turbidity can be used by this, but there are some disadvantages also. So here pathogen killing, microbe killing by biosand filter. So this is also a result of that trade-off. This is also sedimentation with natural coagulants. Horizontal roughing filter. You see this is a filter where water is what water is doing. Water is poured here, then it flows through this channel of gravels or materials of different diametric size. So this is the largest diameter, this is the smallest diameter. So water seep through it, and here we have a treated water which does not have any turbidity or tears, and sometimes no contaminant, no microbes also, as you can see. So this is also a result of the trade-off. And this is another very innovative filter. So the picture says all. So the first thing is that the untreated water is put here. This is for untreated water. And then what happens? It goes through the diffuser. So here it is written protects the top of the sand and the bio layer from being damaged when water is poured into this filter. This is the intake point, you can say. Untreated water is poured here. Then it goes through the bio layer, this one, and microorganism eat some pathogens here in the water, helping the filter treat the water better. That means microorganism get busy in eating the pathogens, so it stucks here, correct? Then it goes to the filtration sand, it filters out, then gravel is there, then drainage gravel is there. Ultimately what happens, it is pumped to this outlet which is collected from this tap. So this is what is, and there is no pump here, this is only gravity that pulls the water. After treating, stored here, due to gravity it comes up and then it goes through here. So this is another innovative method using biolayer. This is very innovative but very expensive also. Solar powered water desalination unit. It can even desalinate the sea water. So this is the solar panel. Let us explain it, nothing to explain, self-explanatory. So solar water is there, solar panel is there. So water sensors are there. The moment it detects poor water quality of this water, it starts the pump. Then the pump pumps out the impure water to this water tank. It gets filtered and then again pumped back to the this tank, this intake tank. So this entire portion is supported by the electricity supplied by solar panels. Okay, this is innovative, this is efficient, but as solar panel cost much, so it is expensive, and due to the sensor cost and all this thing, it becomes very expensive. So there are third method. There are first method was using traditional water conservation methods. Second method was using traditional water filters. And in the last, I have also discussed about how we can make a trade-off between traditional and modern, and we can develop some cheap but efficient filters. So lastly, we have another third method of mitigation. This can be known as adaptation to circular economy. So what is a circular economy? A circular economy is a systematic approach of an economic development designed to benefit business, society, and also environment. So here, to say that this is a system which benefits all. Okay, it benefits the business, it benefits the society, it benefits the environment. In short, it is known as PAC, business, society, environment, PAC. So, in what happened is in that linear model, what happened, we use the resource and waste what is not usable, correct? Here it is saying that don't waste that. You reuse the unusable one, or up to be more specified, you reuse the used resource. This is what is known as circular economy. Let us give you an example. In a street toilet, after you release your urine, some countries are treating that urine, and then it is treating and it is removing all the toxicity from that water, and it is returning back to the toilet for cleaning and washing the toilet after use. So it becomes a zero water filter, or zero water waste filter, or zero waste filter. Sorry, toilet, not filter, toilet. So this is circular economy, using the already used resource. You see, this is resource, you have used it, now reuse it. So it is a circular, correct? So this MacArthur Foundation, Ellen MacArthur has said that an economy that is restorative, just note down the D, restorative, regenerative by design, it is known as circular economy. Very nice. So there are principles of circular economy. There are three principles. Design out waste and pollution, keep products and materials in use, regenerate natural system to avoid the use of non-renewable resources. Okay, you can understood that. Design out waste, minimize waste. That is why people nowadays try to install zero waste products. Correct? So minimize that. And also you have to minimize pollution. You have to minimize waste. You have to minimize pollution. So to reduce pollution, reduce greenhouse gas releasing, reduce release of hazardous substances. Okay, so these are the things that will make you the first principle. Second principle is always remain a material in use. Okay, you first you must design it for durability. Then you must design it. Then you must have a plan of reuse it, remanufacture it, recycle it. Take the example of Nokia mobile phone. It was designed for durability. It was very hard to destroy a Nokia phone. Even if you throw the phone from the four-story building or six-story building, it happens nothing. Yes, some cracks will be there in the screen, but it works. And once that phone is off, the lifetime of the phone is off. For it is over, life cycle is over. Then you try to recycle it, remanufacture it, reuse it. Okay, so this is the second principle. Third principle is regenerate natural systems to avoid the use of non-renewable resources by returning valuable nutrients to the soil. Very important for regeneration using renewable energy. So all these things, what will it do is it will conserve the resource you have, both water, energy, soil, three natural resources that is in store. Try to keep them as it is. Yes, you can transform those resources to different forms, but you try to keep those resources into your system. That is what these three principles of circular economy try to assure. Okay, so this is done, and so there are some benefits. Economic growth will be there, material cost, job creation, innovation scope. Carbon dioxide, the most important one is you can reduce carbon dioxide. Okay, so let us see, land productivity and soil health will also improve. So there are different thoughts of circular economy. So you can go through it, they're not very important. Let us discuss one by one. Regenerative design, I have already said about this. Recycle, remanufacture, refurbish. Blue economy, what is this blue economy? The waste of one product becomes the input to create a new cash flow. That is the byproducts. Okay, what happens is, let us take a case study. Recently, CESC, Calcutta Electric Supply Corporation, has patented their technology of using fly ash. Okay, this fly ash is the biggest byproduct, biggest unused byproduct of any thermal power plant. After boiler boils the coal, fly ash is produced. Now, how to remove them from the campus of the industry? That was a big problem for the designers. So recently, CAC has done something with the fly ash. It has been used for making road or making bricks, and by this way, what happens is they can availability reduce the availability of fly ash in the industry, because managing and storing this fly ash is a big headache for any engineer in that thermal power plant. So this is known as blue economy. Waste product becomes input to another cash flow. Then natural capitalism. So you must devise some methods such that, or modify the production process of some items, such that natural resources can be made to last much long than they can agree to. So sustainability of natural resource, that must be ensured. Then industrial ecology, science of sustainability, biomimicry, natural processes to be followed. So that is why nowadays the performance of, or rather I would say, application of bio-inspired algorithm has gone many-fold, highly beneficial and very innovative. Correct. So that is why biomimicry is required. Now the performance economy. Uh, so they are saying that rather than selling a product, you sell service. That is what they are saying. So performance economy is like that. You try to sell the service, not the product. Now, lastly, cradle to cradle. This thought focuses on design for effectiveness in terms of products with positive impact and reducing the negative impacts of commerce variations. Right? The main thing is that you have to devise a product which is sustainable, which is viable, which is what I would say, which is not harmful to common public. These are some of the characteristics which make a product sustainable. Okay, so make a product uh, or make a product eligible for implementing circular economy. Okay, so these are different school of thoughts. Okay, different ways to achieve circular economy. So let us see how to achieve and implement. Always remember, main issue of the circular economy is this one: reuse, recycle, cascading. So actually, what I say is 3R. 3R means reuse, recycle, refurbish. So this refurbish will not be used much, but this reuse and recycle will be a matter of concern. The difference is that in reuse, the resource is used and then again reused, but its form is same. But in case of recycle, something is already utilized to produce some different product, and then we are trying to utilizing the or recycling the product use uh, to to the initial use. Okay. Now there must be some novel implementation of circular economy. So in case of recycle, you see, we can reuse water. Yes. Water can be reused, not water can be reused. So what happens is you use water for washing. This water become wastewater. So this water and this water is not same. You use treatment to reuse this wastewater as a utilizable water. So this is actually the untreated, unused water. Now it is used, so wastewater is created, and this wastewater, after treatment, can again produce the same water equivalent to the untreated water and to the liquid. So what happens is, what is the advantage of this is amount of water used. You can do this by using Q amount of water time and again. Okay, so this is what is then this leakage of material must be prevented, and we can collaborate. We can incentivize. We can assess to fund, etc. If we successfully transition to circular economy. Okay, so there is a comparison of this circular economy and water conservation. So, see, as you can see that if water use continues down this path by 2030, this is just 8 years away, demand for fresh water will exceed viable resources by 40%. 40% might that. Okay, so you see, this is what is the main thing of the slide. Uh, Now, if you see that according to IW is India, not Indian, it is International Water Association. Okay? And International Water Association says that there are three major obstacles in sustainable management of water. One is the scarcity of water, one is increasing energy price, and the nutrient loading. So it was well managed by introducing the demand management, resource diversification, operational optimization, and okay. So and there are also some regulatory drawback and also opaque market condition. So now we'll see some 5 examples of very well uh, very deserving. So now let us see what happens. They are giving you some examples of circular economy. In water conservation, this is example 1, zero waste management in wastewater treatment. Poland is the location, industries biogas production, and eutropic search. Wherever it releases, wherever it releases the wastewater, what is happening is very easy to estimate. Water going out, uh, it becomes somehow contaminated with hazardous materials. So, and mostly the water is released in a pond or lake like this, which creates eutrophism. That is also not good. Okay, which create eutrophism, blooms, algal blooms that you see in the lakes and ponds. And that is what it says. So it tries to have a zero waste management in wastewater treatment. So well and good, my best wishes to them. Second one is not single country, it is a MENA country. MENA country means Middle East and Northern African countries. Correct? So here they work for minimizing the what? Minimizing the waste or recycling. Okay. Now this is design our waste forward. So at the beginning, you remember that I've introduced the three parts of what I can say. Three parts. So three principles, not three parts. Sorry, three principles of circular economy. So design out and waste water pollution. So this must be prevented. This pollution cannot be there. Then keep products and material in use by harvesting and the same as so that. Okay. And regenerate natural system to avoid use of non-renewable energy. So green infrastructure is utilized like retention tank, green roof, green trail, grass covered tram tracks to prevent water from going out of the system. Okay. So this is example 4, mine and water use and processing. So this 5 is drawn as a surface in promoting cleaner agriculture production. So here the main aim was to do something regarding this hazard due to pesticide and unproductive workers. So three principles were adopted here: monitoring the plant health using drones, optimization of the pesticide and water application using artificial intelligence, how the materials are kept in use, virtualizing the farming process with the help of cloud, and remotely monitored swarm of drones, right? Using ISM here model for decision making. So these are various strategies that can be used to check the products from going out of the system. Here this is recycling. So they have automated the irrigation process. So first method was mitigation method was, let us summarize. Mitigation method 1, traditional water conservation processes. Mitigation method 2, traditional water treatment processes. Mitigation method 3, mitigation method 3. What is that? Mitigation, first one is mitigation method 1, implementation of traditional water conservation procedures. Mitigation method 2 is implementation of traditional water treatment procedure. Then mitigation method 3 is the circular economy, implementation of the circular economy strategy. Correct. And lastly, I could say mitigation method can be the water energy nexus. What is that? In a thermal power plant, management of water must be optimal. Thermal power plant. In a water treatment plant, management of energy must be maximum. Okay, so that is why it is water energy nexus. Right, so they have explained this phenomena. So you see, water is required for the production of energy. Energy is needed for wastewater treatment, desalination, pumping, groundwater, transport of water, etc. Now, rapid urbanization, why water energy nexus is required? That is the answer we are searching for. Why this water and energy nexus is required? Why? Because of rapid urbanization. Because of the social, behavioral, and economic decision, the increased demand on these resources, especially for water energy resources, societies can no longer continue for optimal operation for one system. So optimization is really lacking, correct? We must plan our integration within the FEW systems so that no single one fails, even if it means that all operate suboptimally. As a result, smart nexus in FEW is in need of the water, especially the energy and water resources has to remain a single really such that the other component will be automatically managed optimally. Okay, so what are the what? I have discussed this already. Management of water in energy sector, management of energy in water sector, for measurement of productive can be referred as water energy. Thank you. And let us see what happens. We can do some case studies is given: Brazil, China, USA, where water scarcity is now affecting California. Yes, and drought is estimated to give an economic loss to the state $3 billion in 2015 and $2.2 billion in 2040. So groundwater irrigation will be also very intensive or highly energy intensive, which will be avoided. Okay, so point of concern: India is stressing on energy efficiency in every aspect of life, be it pump, be it car, anything. They are emphasizing on using energy. Solar powered irrigation can be installed, effective monitoring and management. This is what the main thing. Effective monitoring of the management is required to ensure that price will sold from pumping groundwater is insulin is lower than actual cost paid to the power distributor. So this is what is concern point. We need effective monitoring and arrangement of the surfaces. Okay, so let us see the next one. Water energy nexus. What are the opportunities that is there in water energy nexus? Okay, so if you talk about opportunity, yes, sustainable development goal. They have already include this water energy nexus. In case of United Nations, they have proposed sustainable development goal where water is available. Okay, so this is what it is. Let us see. Now let us discuss about 10 innovative examples of water energy nexus. Water recycler, it purify as well as heat water. E-water recycler, grey water is recycled to drinking water. So this is one example of using this water. So yeah, water is purified, it is heated, and then it is recycled. Okay, so power plants to utilize municipal wastewater. That means from municipality, wastewater is being brought to the power plant, which was now utilized optimally. Okay, so these are the things. Now let me find. So in case of American Water, they have developed a technology that is known as NP Express, which decreases the energy in wastewater treatment by 50%. Okay, and the technology is known as NP Express. Okay, NP has already made at 7 wastewater treatment plant meters in America. Has developed a technology that decreases the energy used in the wastewater treatment plant by 50%. Okay, so these are really, so there are examples of wastewater treatment by renewable energy, by solar energy, specifically desalination units are using solar power for their benefit. Okay. Some there is solar, some we can say also wind. Okay, so they have started to do that. So let us see irrigation energy. EDF group has proposed this solution. Electricity funds known as EDF group, which has devised a mechanism to allocate water for irrigation. Correct. So then multi-family energy and water efficiency program. So it's another thing. Austin Water Utility, Texas Gas Service, and Austin Energy. They all developed this beautiful uh, system, multi-family energy and water efficiency program. Right? Who are the part? Austin Water, Texas Gas, and Austin Energy. Okay? In the year of 2011. Now, multi-family energy and water efficiency program is what is aimed at. Okay, so here it is in a more explanatory manner. It is saying to help conserve water, electricity, and gas. This program provides resource efficiency, home improvements for multi-family residential dwelling. Okay, so this is it. We are. Now you see, this is another example. Imagine H2O. This organization, Imagine H2O, promotes the Nexus technology innovation areas of agriculture, water efficiency, wastewater reuse, and energy and resources recovery. Okay, so there are three parts mainly how this circular economy can work. One is wastewater reuse, one is improving the water efficiency, and another one is energy and resource recovery. So, another example, flow through electrode, capacity of distillation, okay, process of desalination to application of electricity. Okay, produces clean drinking water. This is another example. Fresh water from brackish ground or surface water using composite resin electrodes. So this is another one. So this way, fresh water from brackish ground, uh, fresh water from the brackish ground or surface water is utilized by composite resin electrodes and energy, and this energy is used as for ion removal to produce fresh water from brackish groundwater. So here the source is brackish groundwater. Treatment method is by forcing electrodes. That means electricity is a very important thing here, and then it is coming treated water. Okay, so this is what it is, and another one, enhanced renewable methane production system is there. So, so they are enhancing the renewable methane use. This is important. Enhancing the renewable methane production system from wastewater treatment plants, farms, and landfills. This is a low-cost process, accelerates the biological methane production rate. Now, so here another using is happening, that is the use of methanes. Okay, that is a very advantageous thing. Also, patent is pending; it is not very much commercialized. Okay, so here in this long presentation, we have discussed first. We have discussed the vulnerabilities, right? First, we have discussed about the vulnerabilities due to climate change. Then we have said mitigation methods, different types of method, one, two, three, four. In this mitigation method one, actually, it is mitigation method one is traditional water conservation techniques like zaboruza, trenches, rainwater harvesting, bamboo pipes, etc. So these are all traditional water conservation. Then traditional water quality improvement or traditional water treatment. There are 5 different ways we can treat as you have described. One is through sieve pipe, another one is cloth, another one is so like this. There are five different ways where you can use traditional methods to treat water. Okay, so let us go for another thing. So this is all, and there are some. So mitigation method was I was discussing. Mitigation method 1 I have discussed. Traditional water conservation. Mitigation 2 traditional water treatment. Mitigation method 3 and 4 I have not discussed. First one is circular economy. Implementation of different principle of circular economy. Mitigation method 4 is water energy nexus. Let water energy nexus happen optimally. So I have described some 10 examples. Enhanced renewable methane production system. Then you have freshwater color production from brackish groundwater by using electrodes. Then electrode capacity desalination. Emerging H2 acceleration program in agriculture. Multifamily energy and water efficiency program. EDF groups water allocation in irrigation, water and energy generation. Wastewater treatment by renewable energy. Then NP Express, where the cost or the use of energy in wastewater treatment was reduced by 50%. Using municipal wastewater for power generation, recycling the utilized water from sewage flow. So these are all 10 innovative examples of water energy nexus. So with this, I'll finish this presentation. Thank you.